But anyways, so M1 is 2 kilograms. M2 is 3 kilograms. V2 initial was minus 1 meter per second. V1 initial was 2 meters per second with a plus sign. So here is all my knowns from the original problem. Can you see that V1 final is equal to, so it's the difference, M1 minus M2, so 2 kilograms minus 3 kilograms. That's a weird thing. I'm going to get a negative sign in that, times V1 initial. V1 initial is positive 2 meters per second. So that's a times. And then the instruction is add to that twice M2, so 3 kilograms, multiplied by V2 initial minus 1 meters per second. And then divide the whole thing by the sum of M1 and M2, 5 kilograms, like this. So just a little bit of math. 2 minus 3 is minus 1. Minus 1 times 2 is minus 2 kilograms meters per second. That's that part. Plus 2 times 3 times minus 1 is minus 6 kilograms meters per second. And then I divide by 5 kilograms. This is equal to, so minus 2 minus 6 is minus 8. And then I get, I have to divide by the 5. The 5 is still here. The kilograms, there's kilogram units in each of the terms upstairs and also downstairs, so they can all mutually cancel each other or divide each other away. And of course we're only left with speed units because we just calculated a velocity. It looks like object number 1 after the collision moves backwards. So here's 1 and 2. Collision happens, and after the collision, I'm not so sure what happens to number 2 yet, but we're going to go solve for it. Number 1 goes backwards, and this is just a little bit less than 2 meters per second leftwards, right? A little bit less than 2 meters per second leftwards. So actually, it almost looks like this thing just bounces back with exactly what it came in with, except for just reversed. But not quite, right? So this is a full 2, and this is just a little bit less than 2. Can you see if that was a 10 over 5, then that would be 2. Yeah, so instead of a 10, it's an 8. V2 final. This will be interesting. M2 minus M1, so 3 kilograms minus 2 kilograms. Multiplying V2 initial. V2 initial is this negative 1 meters per second. So multiplying there. And then plus 2 times M1. Oh yeah, M1. M1 is 2 kilograms. Excuse me, 2 kilograms. Multiplied by V1 initial, which is positive 2 meters per second. Like this, and then I divide by M1 plus M, or it does it backwards, right? Because we imagine we can switch the labels. So that's another 5 kilograms on the bottom. So the top is plus 1 times minus 1 kilograms meters per second. And then a plus, and then 2 times 2 times 2 is 8 kilograms meters per second, and then I divide by 5 kilograms. You can see the same thing happens with the kilograms. They all mutually knock each other out and left over only with meters per second. So 8 minus 1 is 7. 7 fifths kilograms. Whoops. Just meters per second. We're calculating a speed. We expect only speed units. So interestingly, the 3 kilogram object, the object on the right, after the collision, actually, they both separate from the place of collision. So here they come, opposite directions, they collide, and it could have been, right, one of the things that could have happened is they collide and then they both drift leftward. That could have happened. Another thing that could have happened is they come in and then they both drift leftward after the collision, or they go in and then they leave opposite directions, and that's in fact what happens. Earlier, I alluded to an algebra problem that you could solve. It's basically that you have these two equations. One is quadratic in speeds, or actually quadratic in velocities. It's quadratic in the velocities, one of them is, and the other is linear in velocities. That makes them seem extremely different, but they are in fact different relationships. So they are in fact linearly independent. So they're genuinely two separate equations that are linearly independent with two unknowns. Should be solvable algebraically. And I told you that in a book you could find the answers, the solutions to solving the algebra problem. Here they are. The truth is that problem is pretty hard. This algebra equation, or the two things that you have to do the algebra with, are really complicated and tangled. So I thought I might spend a couple of minutes, or a video or two, honestly, trying to explain how you can get these answers. But I'm going to do something of a trick. So I'm going to solve this. I'm going to solve this algebra problem with a trick that is inspired by being a physicist, right? And the trick is to solve, this is kind of funny. The trick is to solve an easier problem first. So that's funny. But yeah, let me show you the easier problem. So original problem kind of looked like this. Had an object, number 1, headed into a collision zone, and number 2 is also headed into that collision zone. They're going to have elastic interaction, and number 2 leaves the collision zone, and number 1 leaves the collision zone. So, so this was the initial, and this is the final, right? Before and after the collisions. So, simple problem, or simpler problem. Let's not let number 2 move at all. So what I mean by that is, let's take the problem of number 2 being at rest and number 1 heading in to hit it. And then, so this will be the initial. And in the final, the truth is kind of who knows. Number 1 could keep going in the same direction in the final, and number 2 moves away faster, right, so that they're never going to collide again. Or number 1 bounces backwards pretty fast as well. So number 1, it's not clear whether or not number 1 keeps moving after the collision towards the right, or does number 1 fully bounce backwards. And that depends on whether or not M1 and, or like the relationship between the masses of M1 and M2. If M2 is very massive, number 1 is going to bounce backwards. But if M2 is really, really light, like this is a bowling ball and that's a ping pong ball, a bowling ball and a ping pong ball will do more like this. So it depends on M1 and M2, but the simpler problem is to start V2 initial equals to 0. So then P total initial equals P total final. This relationship is pretty simple. It just looks like M1 V1 initial, and then m2 v2 initial is 0 equals m1 v1 final plus m2 v2 final. And then this is elastic. It's an ideal elastic collision, so the kinetic energies are going to total up to be the same before and after the collision's finished, and that leads to a relationship. So in the initial, right, number 1's got kinetic energy, but number 2 does not. So this is 1/2 m1 v1 initial squared equals, and now they both have kinetic energy in general. So this will be 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. Right, and so in this simpler problem, where v2 just simply starts at rest, it's not nailed down, it just happens to be a situation where it neither has momentum or kinetic energy to start with, which is, possible. That situation gives rise to these two equations. So let me think a second here. So if I want to solve this, let me try to solve, let's try to get v1 final first. So if I want to try to get v1 final first, here's how I'm going to do it. I want v1 final first, so if I call, let's call this equation A and this equation B, right? Let's solve for v2 final in equation A. And the reason I'm going to do that is if I get v2 final, right, pretty easy, right? In A you can get v2 final in terms of v1 final, v1 initial, and all the masses. I can take that v2 final and square it and put it in there, and then the second relationship will be all about v1 final, which is our goal. So let's solve for v2 final in A. So solving for v2 final in A, what that's going to give us is m1 v1 initial minus m1 v1 final, right? I'm going to subtract that to that side, and that leaves over m2 times v2 final, and I'll divide through by m2. So this is times 1 over m2 equals v2 final. And now square this. So if I square this relationship here, I get v2 final squared equals 1 over m2 squared, right? 1 over m2 has to be squared if I square both sides. And then the square of this. And the square of this thing is m1 squared v1 initial squared plus m1 squared v1 final squared. So this squared plus this squared minus, right, or plus 2 times this times that. So this is the FOIL, so you get minus 2 v1 initial v1 final. So, and that is all multiplied by this 1 over m2 squared. Sorry for the discontinuity, but I am missing a factor of m1 squared in here, so I'm going to just put it in, and I hope that you can still follow along. So there is an m1 squared sitting here, and it came from the cross term of this times this, so it's m1 times v1 initial times v1 final. So there's an m1 squared here, and now I'll continue. Yeah, sorry about that.